So now what we're going to do is take a look at how big of a sample size would we need to get for us to construct a confidence interval. So this formula you're seeing up here, this is what we use to calculate our error at the beginning of this section, but we can kind of work around and solve that to find what our sample size would be. So I just want to remind you that this z alpha over 2 value, these are those critical values which can be found on the formula sheet for 90, 95, and 99% confident. So if we know p hat, or if we know a population or a sample proportion, we can use this one. If we do not know p hat, we're going to work with this one. We have to always round these up. So let's take a look at this first one. It says find a minimum sample size required to estimate a population proportion or percentage, margin of error 5%. So that's our error, 0.05. Confidence level would be 0.90. And finally, it says p hat is estimated by 0.58. And if you take a look, I need to know what q hat is in as well. So if p hat is 0.58, we do 1 minus 0.58 to find q hat. So that would be 0.42. So let's take a look and see if we can figure out how to plug into this formula. So n is equal to z alpha over 2 squared times p hat times q hat divided by our error squared. So let's plug those values in. If our confidence level is 90%, what would that critical value be? We're going to use the critical value of 1.645. So it's going to be 1.645 squared times p hat, which is 0.58, times q hat, which is 0.42, divided by our error, which is 0.05, and then make sure you square that. Biggest mistakes I see students make is they forget to square these values. So let's use our calculator and work that out. So it's going to be 1.645 squared times 0.58 times 0.42, and then I like to work out the top first, and then we're going to divide that by 0.05 squared. And I get 263.68, which, like I said earlier, we will always round these up. It's like basically like a floor. You can go above it, but you can't go below it. And I can't go talk to 2.68 people, so we need to round this up to the nearest whole number of 264. All right, let's take a look at one more of these. So Toyota provides an option for a sunroof and side airbag package for $1,400 for its Corolla model. A Toyota wants to determine the percent of Corolla buyers who would pay an additional $1,400 for this package. We don't know the critical value, or we don't know a p hat value because we don't know what percent of people would pay for this. We want to be within 3 percentage points, so that tells us our error is going to be equal to 0.03. And we want a 95% confidence level, so that z alpha over 2 value is going to be based off of our formula sheet, and we look at that, our 95% value is 1.96. All right, and then we're going to use this formula right here. So if you take a look, it's just the only values we need are a critical value and our error. So n is equal to z alpha over 2, which is 1.96, squared times 0.25 divided by our error, which is 0.03, and then we're going to square that value. So it's going to be 1.96 squared times 0.25 and then we're going to I'm going to delete that. We're going to hit enter because I like to work out the top first. You don't have to in this case, but it's a good habit to get in just in case. Divide that by 0.03 squared and we get 1067.11. Now, again, what I'm saying is no matter what, you need to round up. I can't go talk to 0.11 Corolla buyers, can I? But I can round that up, and I can talk to 1,068. You can always go above this value, but this is the minimum value.